I want to determine the lengths of all the sides in this particular kite. This applies one very important property of kites, and that's that the diagonals are perpendicular to each other. Now, judging by the labels of the insides of this particular kite, I can tell that these two sides are going to be the same because they both contain an 8 and a 9 in the right triangle. These bottom two sides, BU and UT, will also be congruent because they both right triangles contain 9 and 7. So I really only have to do the Pythagorean theorem 2 times. So I'll start here with this triangle, the 8 and the 9. Sometimes it helps to draw the triangle outside the picture. So I have to apply the Pythagorean theorem here. I will say 8 squared plus 9 squared equals c squared. Now, 8 squared is 64, and 9 squared is 81. (64) and 81 combined together give me 145. Now, when I square root both sides, I do not believe that 145 is a perfect square. So I will need to reduce this radical if I can. So I'm going to make a factor tree. I know that 5 divides into 45 29 times. But since 29 and 5 are both prime numbers, I can't reduce this radical any further. So my answer is simply the square root of 145. For both this measurement here and its equivalent measure, ST and SB. Now, let's look at the bottom triangles. And it appears that one side of the triangle is 9, and the other side is 7. So I again set up the Pythagorean theorem the exact same way. 9 squared plus 7 squared equals c squared. 9 squared is 81 plus 7 squared, which is 49. 81 plus 49 equals 130. Now again, I have to square root both sides of the equation. And I want to think to myself if 130 can reduce. So I'll make a factor tree. I know that 13 and 10 multiply to give me 130. 10 breaks down to 5 and 2. So since I don't have any pairs of numbers, the square root of 130 has to be my answer. And again, since this is a kite, this will be the answer for 2 of the 4 sides. It is the answer for VU and the answer for UT.